it will be like this. If the wavelength is large, it will be like this. So the smaller wavelength, there is no chance of hitting to the atom. Larger wavelength also, there is no chance of hitting the atom. If I hit that, if I project the angle, if I project this in a different angle, it will not hit. Traveled by DE and EF is GE and EH. If you remove the GE and EH, you just cut this. If you cut this and join these two, it will be equal to ABC. Hi, today we are going to study about X-ray diffraction in a short form related to pharmacy. So, if you want to analyze a crystal, then you need to take X-ray. You need to project X-ray on the crystal. Then you need to analyze it. So you can ask me, sir, why only X-rays? So before that, you can ask me like, sir, we can use other electromagnetic radiations like UV, IR, visible, etc. Why not those? Why this X-ray? The reason for this is X-rays are the electromagnetic radiations which have a wavelength of 0.01 nanometer to 10 nanometer. So this wavelength, so the wavelength of X-ray is equal to interdistance between two atoms. So the wavelength is equal to the interdistance between two atoms. So the wave of X-ray will sit between the distance between the two atoms. Why I am telling this reason? If the wavelength is small, it will be like this. If the wavelength is large, it will be like this. So the smaller wavelength, there is no chance of hitting to the atom. Larger wavelength also, there is no chance of hitting the atom. The wavelength is exactly to the distance between two atoms, then there is a chance that your X-ray wave will hit that atom. We want that radiation to hit the atom. That is the reason we are selecting the X-ray here. Now straight away we jump into the analysis of crystal. So crystal, we have many atoms in the crystal like this, different planes. This is the one plane, this is the plane 2, this is plane 3. It's a different planes. Now the distance between two planes, we call it as a interplanar distance. To analyze the crystal, remember, to start this, you need to have 2 points in your mind. To analyze the crystal, you need to find out two things. One is, what is the angle of incidence and angle of diffraction of X-ray, angle theta, and what is the interplanar distance. If you can find out these two values, you can characterize the crystal. Remember, to analyze or to characterize the crystal, you need to have these 2 points. Then only you can characterize the crystals. So remember this, I need to have these 2 points. Now to move on, we need to have theta and interplanar distance to characterize the crystal. So our aim is to analyze the theta value and interplanar distance value. So before going to this analysis, you need to know what is the instrumentation of X-ray. X-ray instrumentation, if we take this is as a sample, there will be one thing which will be emitting X-rays, and there will be one thing which is receiver, or you can say detector. Detector will be there, or receiver, or you can say source of X-rays. This will emit the X-rays on the sample. This is sample. This will emit the X-rays on the sample, and the diffracted rays will be collected by the detector. This source and the detector will move like this. They are movable. Your sample will be stagnant. This will move from here to here like this. This will also move from here to here. So why they are moving? Because we need to project the angle in a different, we need to project the X-ray in a different angle. Why? Reason is, in your crystal, the planes, maybe it will be like this, or it will be like this, or it will be like this. We don't know. So if I have to project only in this angle, then only it will hit. In this case, I have to project in this angle. In this case, I have to project in this angle. I have to project only in this angle, then only it will hit. In this case, I have to project in this angle. In this case I have to project in this angle, then only the X-ray will hit the atom and it will be diffracted. Other than this angle, for this type of crystalline arrangement interplanar, it is not possible to get the diffraction. So diffraction means what? Your atom is there, X-ray will hit this atom, then it will be diffracted. So this is the diffracted ray, this is the incident ray. So to get this diffraction, you need to hit in particular angle. This angle is dependent on the arrangement of planes in the crystal. So the planes are also in a different angle, hence you need to rotate your source as well as detector. So both source and detector will project the X-ray in a different angle. So from where they are diffracted, it is collected by the receiver. So that is the reason why they are movable. Now how to analyze the crystal? There is a law called Bragg's law. So by using Bragg's law, you can analyze or you can characterize the crystal. So Bragg's law, the simple statement of Bragg's law is path difference is equal to integral multiple of wavelength. Path difference is integral multiple of wavelength. That was the statement given by the Bragg's law. What is this? We will try to see here. So let's say I am projecting two rays. One ray is this one, which is hitting here and it is going like this. Another ray is this one, hitting here and it will be diffracted like this. So this will be angle of incidence, this is the angle of diffraction. So theta and theta. Now we have a distance here, that is interplanar distance. We will give the coordination to this. So before giving the coordination, let's say this is A, B and C, ray 1, D, E and F, ray 2. So we are studying only about the two planes here. We have many planes in the crystals. So your X-ray can pass through the many planes. For a time being, assume that we are analyzing the two planes. Okay. Now this is the diffracted ray of first, this is the incident ray, this is the diffracted ray of first wave. So extrapolate this diffracted ray until it touches the incident ray of your second wave. Next, extrapolate the incident wave until it touches the diffracted ray of first wave. So give the coordination for this, the point where they are touching. So D, E, F, G and H. So these are the coordinates given here. Now to analyze, he says path difference is integral multiple of wavelength. What is this? We will try to see. So A, B and C is the first X-ray. It is having some path. So it is the first X-ray. Second ray is D, E and F. This D, E and F is traveling extra path compared to A, B and C. What is that extra path which it is traveling is G, E and E, H. I'll write this G, E and E, H. This is the angle theta and this is also theta. Okay. So the extra path traveled by, listen carefully here. So if you miss this, you won't get that. So the extra path traveled by D, E and E, F is G, E and E, H. If you remove the G, E and E, H, you just cut this. If you cut this and join these two, it will be equal to ABC. In D, if you cut G, E and E, H, if you cut this two, this one and this one, if you cut this and join these two, then it will be equal to ABC. So means what? The extra path traveled by your D, E, F is extra path. We call it as a path difference. What is the difference in the path which is being taken by the D, E, F is extra path is G, E plus E, H is the extra path traveled by your D, E, F. This is the extra path, or you can say path difference. So now come back. I given you a statement to analyze the crystal, you need to find out two things. One is your angle of theta, another is path difference. You need to interrelate these two things, then only you can analyze this. So that thing is done by Bragg's law. He says path difference is integral of multiple of n lambda. So what is the path difference? GE and EH is the path difference, which is equal to the n lambda. So this is your path difference or extra path travelled by the second wave. You have many waves there. So if depending on the layers, n is the number of layers. Okay, n indicates number of layer, lambda indicates the wavelength, and theta indicates the angle of incidence or diffraction. So extra path travelled by DEF is n lambda. So we need to find out what is the value of this GE and EH. For that you need to take the triangles here. We have two triangles here. One triangle is BG and E. So take triangle BG and E. So it is a right angle triangle. We have theta here. Apply sin theta. So in triangle BG and G, sin theta is equal to opposite side by hypotenuse. This BE will be hypotenuse and GE will be opposite side. So GE opposite side by hypotenuse is BE. Next, what is your triangle? Take another triangle here, BEH. So in the triangle BEH, what is the opposite side? EH, hypotenuse is BE. EH and BE. What is BE? BE is your D. So BE is your D. I will write this one here. So sin theta is equal to GE by D, and sin theta in triangle BEH, sin theta is equal to EH by BE. EH by BE, or you can say it as D. So what we need here? We need the value of GE and EH. So take GE. If you take GE here, so it will send D here. It will be G is D sin theta plus what is the value of EH? See here. EH is here. Send this here. It will be D sin theta. D sin theta, which is your path difference equal to n lambda. So if you add this, you will get 2D sin theta is equal to n lambda. This is the equation through which you can analyze or characterize the X-rays. This was the X-ray diffraction studies in short. Okay, if you get the values of theta and lambda, you can analyze. So that's what it is, X-rays. Okay. I hope you understand. Thank you.